Okay, you only have 30 seconds for this one. Okay, this is very easy. This is actually, it has been 8 years since I took my O-levels. Okay, can you guys type out your answer if you're ready? Okay, I got 9 students already. Type out your answers. Okay, this is actually your Sec 2 probability. This is actually not O-level stuff yet. Yeah, some of you who still remember your Sec 2 work, you can write this down. Okay, so these are some of the accepted answers, guys. Okay, now, please, okay, so just for this question, I'm accepting answers that are not simplified. Okay, so if you have a fraction like 6/9, right, please simplify your answer so that, yeah, and so that, because after this, I'm only accepting answers that are fully simplified. Alright, so don't leave your answers in the unsimplified form. For fractions, leave it in the simplified form. Okay, and then for fractions, we are going to type out our answers like this lah. So for example, if you have 2/3, we write it as 2/3. Alright, so this is how it's done. Okay? Hi, those of you who just joined us, this is just the first game. Okay? Yes, coach, yes, lucky I still remember you. Okay? Now let's take a look at how you guys fared for the first game. Okay, now scoreboard, we have Lovely Octopus and Golden Jaguar. Wow, same points, 850 points, and the rest of you are slightly below. Okay, but it's just the first game, so no worries. Alright, Aiden is trying to deceive us with wrong answers. You must play fair, Aiden. Hi, Sophia. Okay. Alright, are you guys ready for the next game? Okay, the next game also not going to take, it's going to be quite short, a few seconds only. Okay, get ready, Okay, I'm going to click on the next question. Okay, sorry, not next question yet. This is the answer. Sorry, I forgot. Okay, so in this is actually a lower sec probability question. Alright, I think some of you who have been going through Sec 2, you will remember this, right? Okay, so you have 6 red balls here, 2 white and 1 blue. A ball is taken from random. Now, just a quick recap one again. To find the probability of an event E, right? What we do is we'll take the number of favorable outcomes and we will divide it by total number of possible outcomes. Now, what do I mean by possible outcomes and favorable outcomes? So let's take a look here. In this case, when you want to find the probability that the ball is red, your favorable outcomes are the red balls. Okay, whereas for us to find the total number of outcomes, we're looking at all the number of balls here. Alright, so the answer is 6/9, okay, which we will simplify to become 2/5. Okay, Rizla, can you hear me? Is it a... Okay, can? Alright, so this is actually Sec 2 work. Alright, let's move on to the next question. So as we go along, it'll get tougher and tougher. I'm just going to warm you up with the lower Sec stuff first, and then we will go into the real deal, the Sec 4 stuff in a while. Okay, so next question, let's move on. Okay, this one also, question 2. Let's take a look at this one. Aiden flexing, Aiden. Okay. Okay, read carefully, guys. It says here, what's the probability that he does not take the car to school? Alright, so we are yeah, good. You can use a calculator, go ahead. Alright, yeah. No problem. Okay, those of you who haven't keyed in your answers, you have 15 seconds left, not much time. Yeah, the first 2 questions are quite easy, Aiden, but it'll get tougher as we go along. Yeah, we have altogether 13 questions, so we are just on our second question. Okay? Alright, so this is the answer. Okay, you can either write it as 0.8 or 4/5, the equivalent. Okay, like I said, guys, moving forward, I will not be accepting any fractions that are not simplified. Okay, otherwise there are too many to cater for. Alright, so we'll just stick to the simplified fractions, or if you want to write it in decimals, if it's a nice decimal, you are free to do so as well. Alright, so good, 13 of you got this right. Let's take a look at how this is done. Okay, wow, there's some change to the leaderboard so fast. Okay, Clever Penguin is indeed very clever, so he's in number 1. Okay, he or she is in number 1. Mystery Finch is number 2, and Dynamic Panda is number 3. That's nice, that's nice. Okay, it's just the first 2 games, and we're seeing quite a number of displacement already. So let's take a look at how this is done. Okay, now these are what we call complementary events, guys. Okay, those of you who have learned set notation, you guys remember complementary event whereby you have like the A prime, B prime. Okay, this is for O levels. Okay, this is for our O level students. Yeah. Alright, so basically when you taking the car and not taking the car, these are two complementary events. It's either you take the car or you don't take the car. So the probability of taking the car and the probability of not taking the car, okay, the probability of taking the car or not taking the car will give you one whole. Alright, so to find the probability that he doesn't take the car, we can just take 1 minus 0.2. Okay, so you got to bear in mind here, this question a little bit tricky because there's a possibility that he might, because if you guys were to actually observe the question here, right, notice that you look at the bus is 0.7, whereas the car is 0.2. If you add them up, right, it's actually equals to 0.9, not equals to 1. So why is this? Have you guys thought about it? How come if I add the 0.7 and 0.2, I don't get 1, I get 0.9? What does that say about this question? Or what does that say about ND? Okay, can you guys type in the chat, what do you think? How come the probability here don't add up to 1? We all know that probability must always add up to 1 whole, right? But in this case, if I take 0.7 plus 0.2, it doesn't add up to 1. Why? Xuan gave a good idea, good suggestion. Yeah, there's a 0.1 probability, there's a 10% chance, or there's a 1 out of 10 chance, right? Where she might be walking, or he might be, there's some other means of transport that we haven't taken into account for. Okay, not bus, not car, something else. Yeah, so that other way would probably be 1 over 10. That's a probability. Okay, yeah, flying, if he can fly, then that will be an option. Xuan. Okay. All right, let's take a look at the next one. Are you all ready for the next one? Question 3. Okay, here we go. Let's go. Okay, read the question carefully, guys. So we got Alice and Bernice here. Swimming competition. Probability of Alice winning is 1 over 3, sorry. Probability of Bernice winning is 1 over 4. Okay, find the probability that either Alice or Bernice wins the competition. Okay, so we're still into simple stuff still. We haven't gone into the real deal yet. Hi, those of you who just joined us, you're free to join in the game. The game pin is 6963856. All right, you're still free to join in the game. We are just into our third question. There are 10 more questions to go after this. All right, so just those of you who just joined us, yes, the main idea today is actually a revision for probability. Okay, and but the side quest is to win the $10 popular voucher. Okay, good. 7 of you got this right. Let's see how the leaderboard changes. Clever Penguin is indeed clever. So she's still keeping his #1 spot, but Eagle Zebra is just 1 point away. Okay, so very close. Super close this one. All right, let's take a look at how this is done. Okay, now the idea that I want to get across to you by giving you this question is to highlight to you that when it comes to an or, right, in probability, okay, you can just translate that or to a plus. Okay, when it comes to probability, when you have or, it translates to a plus. Okay, so you can just add the two probabilities together, the probabilities of Alice winning plus the probability of Bernice winning, and that's how we get the answer. Okay, so for an or, it translates to a plus. Aiden, you like my hairstyle, is it? Okay, can. So remember, if it's an or, you plus. Later on, I'm going to show you another one, and. Let's see what happens if you an and. Can we move on to the next question? Okay, question 4. Okay, you have 90 seconds for this one. Okay, so Rahul has 9 shirts. Okay, and they have various colors, red, white, and blue. He has 5 pens, 3 black and 2 brown. Now you want the probability that he randomly selects a white shirt and brown pants. Okay, how many of you here go to your closet and you randomly just pick up your clothes without looking at what they are? Or I cannot answer your question, Aiden. I've never gone for that fate before. Yeah, 1 pants and 1 shirt. He's selecting 1 shirt and 1 pants. Okay, Aiden, I'll take your advice next time. Those of you who haven't keyed in your answers, you have 19 seconds left. Hi guys, those of you who just joined us, I'm Coach Hakim from MasterMaths, and today we're actually doing a revision on probability. So we're actually catering to the O-level students today, and we're revising probability in view of the upcoming WA. None of you got this correct. Oh, 7 of you got this right. Nice. Okay, that's good. All right, let's see how this is done, guys. Let me explain to you. Okay, any changes to the leaderboard? Well, first and second. Okay, Clever Penguin has increased his lead by a bit. Okay, but we have some changes at the bottom, third, fourth, and fifth, quite volatile actually. Okay, let's look at the next one. Let's look at question 4. Okay, so you have 9 shirts here, right? And which is made up of 2 red, 3 white, and 4 blue. Okay, 5 pants is made up of 3 black and 2 brown. Now you want to find the property that he selects a white shirt and 1 brown pants. Alright, so when just now, remember when we were doing question 3, when it was an or, we translated it to become a plus. Okay, so when it comes to and, it's going to become a times. Okay, so or translates to a plus, and translates to a times. This is how you remember it, guys. Okay, so remember this, or translates to a plus, whereas and translates to a times. Okay, so what we do is we find the property of finding the white shirt first, which is actually just 3 over 9, since there are 3 white shirts out of 9 total shirts altogether. Okay, and then we find the property of getting 1 brown pants. So you got 2 brown pants out of 5 pants altogether, right? And we multiply these 2 together. Yeah. Okay, so that's how we actually arrive to the answer of 2 over 15. Okay. Yeah, so if it's an and, you multiply. If it's a or, you plus. That's how we remember it. Okay. Okay, now let's take a look at the next one. You guys understand? Can I proceed to question 5? Thanks, PT, for sharing the live. Really appreciate it. Thanks. Okay, question 5. Let's move on to the next one, guys. Okay, now over here you have balls of equal size, a bag containing balls. 12 blue, 6 are yellow, and the rest are white. So the number of white is an unknown. Alright, now you are given that the probability of drawing a blue ball is 3 over 7. Now you want to find the number of white balls in the bag. Okay, yeah, so focus on the blue ball, guys. Okay, just give you a hint here. Focus on the blue ball. Okay, blue is the color to go. Hi, those of you who just joined us, I'm Coach Hakim from MasterMaths, and today we're actually doing a revision on probability, okay, for our O-level students. So if you're an O-level students, it's not too late to join the game. We're just at question 5. Okay, go to Kahoot and log in the game. Okay, the game pin is 6963856. Okay, you can still join us. There are still another 8 more questions after this. I'm not going to say who's right, who's wrong. By the way, they're asking for the number of white balls, not the probability. Can you read the question carefully? They're not asking for the probability of finding a white ball. They're asking for the number of white balls. I don't want to say, Aiden. Not until everyone has keyed in the answers. Okay, we still have about 30 more seconds. Those of you who have not keyed in your answer, you can key in now. Hi, Gogi. Okay, this is actually for O-level students. Can you guys still hear me? Testing, 1, 2, 3. Can Okay, yeah, this is actually for Sec 4 and Sec 5. Yeah, O-level students. Alright, good. Yeah, so you all write down your answers at 10. Well done. 9 of you got this correct. Let's see how this is done. Any changes? Oh, wow. Eager Zebra is showing his or her eagerness in the game and now overtaking Clever Penguin. Alright, so let's take a look at how this is done. Okay, now, so we are told that there are 12 blue, 4 yellow, and the white is an unknown, right? Okay, now what we are told is that the property of getting a blue ball is 3 over 7. Now what I did was this, okay? Now the 3 over 7, right, the 3 units out of 7 units, the 3 units must represent the number of blue balls, which is 12. Which is why I use 3 units represent 12 balls. Okay, now just find 1 unit first, and then find 7 units to find the total number of balls. Okay, that will give us 28 balls in total. So when we just take 28 minus the number of blue balls minus the number of yellow balls, you are going to get the number of white balls. Okay, so those of you who get this 10, well done. Okay, those of you who didn't get it, it's fine. This is a learning opportunity for you. Okay, all right, so let's take a look at the next one. Okay, question 6. Okay, hi, those of you who just joined us, welcome to our live. Okay, we are into our Kahoot game. Today is a session meant for our Sec 4, Sec 5 students, O-level students, and we are doing on the topic of probability today. All right, so this is a revision, a free revision for everyone who are going through your WA1 in a while. Yeah, Prince Potter, we are doing O-level probability today. Hi Maria, those of you who just joined us, hi, good to see you. Okay, you can actually join us in the game. We still have another 7 more questions to go. All right, this is the 6th question. Okay, do take your time to read the question carefully because it's, yeah, you have to be careful here. It's actually related to the previous question. Prince Potter, which level are you at? Are you a Sec 4 student? Hi Amanda. Hi Kai. Sec 4. This is a good opportunity for you to revise your probability. Is it going to be tested for your WA1 in your school? This is a good time to join us. Okay, you join in our Kahoot game. We still have another 7 questions more to go. This is the 6th one. There are 13 questions altogether. All right, yeah. Okay. Hi, those of you who just joined us, this is a free live stream from MasterMaths. I'm Coach Hakim, by the way, and we're doing a free live stream on the topic of probability for our O-level students. So if you know of anyone who's an O-level student, your neighbor, your friend, your relative, please share this with your, please share this with them, all right? So that more people can benefit from this. Oh, Luke, have you tried the questions? Okay, so the answer is 8. Quite a number of you got this right. Okay. Now, all right. So Expert Unicorn is also showing her expertise, his or her expertise in the game. All right, getting to number 2. All right, that's very close. Let's take a look at how this is done. Okay, now this one here involves a bit of algebra. Okay, let me just explain to you guys. So what I did was, originally our probability to find so the original probability of getting a yellow ball, right, would be 6 out of 28. That's the original probability of getting a yellow ball before we actually added in the new balls. Okay, what happens is after adding in the new balls, right, okay, we have to add in x to your numerator. So what I did was I let x be the additional number of yellow balls. I added x to the numerator and I added x to the denominator. Okay, because the number of yellow balls is now 6 plus x. Okay, whereas the total number of balls will also increase by x. So which is why in the denominator we have 28 plus x. Okay, and that is the one that I equate with 7 over 18. Okay, so this will be the new probability which will give us 7 over 18. So the next step, the second step was me just cross multiplying. Okay, 18 gets multiplied to the numerator on the left and 28 plus x is multiplied to 7 on the right. Okay, so after expanding and simplifying, you get x equals to 8. Okay, that will be the number of additional balls that was added to make us get that 7 over 18. Can? Do you guys understand this question? Okay, good. Now let's move on to the next one. All right, let's take a look at the next one. What happened? Okay, question 7, guys. Let's get ready for this one. Okay, you have a 4-sided die and a 6-sided die. So you got 2 die here. Okay, ikan bilis, you can join us because this will be relevant, right, to what you're learning at poly, right? Yeah, so which poly are you from, by the way, ikan bilis? Okay, so you got 2 die here. One is a 4-sided die and another one is a 6-sided die. Okay, now you're asked to use a possibility diagram here. So can you guys just quickly draw your own possibility diagram on a piece of paper? Okay, for you to use your diagram to help you visualize, to see all the possibilities that you actually get from this, from throwing these 2 dice. Wow, so fast 2 students answered already. That's fast. Did you like visualize your possibility diagram in your mind? Okay, yeah. One is a 4-sided die and another one is a 6-sided die. Okay, so hi Sharul, welcome to our live. I'm Coach Hakim from MasterMaths. Okay, you still got about 80 more seconds, guys. Take your time. Okay, unless you're aiming for the voucher, then that one cannot take your time. Ikan bilis, which poly are you from? Hi Hashrin. SP, okay. Who's your math teacher there? Yeah, maybe Luke, it's actually meant for the O-level students, the Sec 4, Sec 5 students. Yeah, so probably it's a bit, might be a bit too challenging for you considering you're still Sec 1. Okay, but now you can just follow us and see how we go about doing it. Yeah, you don't have to get it right, but you can just see how this is done lah. Okay. Did you guys really go and draw out your possibility diagram? Hi, thank you so much for sharing the live. Hi, Chocolate Boy. Hi, Dora, you're back. Okay, let's take a look at how this is done. Okay, the answer is actually 5/12. Okay, 4 of you got this correct. Now, let me explain to you how this is done. Okay, expert unicorn showing his or her expertise, okay, even overtaking eagle, zebra, and clever penguin. Okay, let's take a look at how this is done. Alright, so now what you can do here is to draw your possibility diagram. Okay, a possibility diagram is basically like a table which shows you all the possible outcomes that you can have. Alright, so because of the fact that so for the 6-sided die, the outcomes will be 1, 2, 3, 4, 5, 6, right? The 4-sided die outcome will be 1, 2, 3, 4. Okay, so what happens here is that in this possibility diagram, okay, because the question wants you to find the sum of the 2 numbers, this is why instead of writing it as like coordinates, some of your teachers teach you to actually write down the elements inside the table as coordinates, right? Like 1, 1, 1, 2. In this case, I would actually change it to become an addition table. Because why? The question wants you to find the probability of the sum of the 2 numbers. So it makes sense to actually change this to become an addition table, which is what I have here. Okay, then it becomes very clear because when the question says at most 5, they are looking at numbers less than or equals to 5. Alright, so there are 10 numbers altogether out of a total of 24 possible outcomes. So these 10 are the 10 favorable cases out of the 24 total outcomes, and that's how we end up getting 5/12. Good look. So you see, you can do, right? Okay. Are you guys okay? So the next question is also going to be on possibility diagram. Okay, let's move on to the next one. Okay, this one interesting because you have a box that contains numbers 1, 2, 3, and then you also have another box, a second box, but the second box do not contain numbers. This one contains colors. We have red, green, blue, and yellow. Alright, so these are, so it's a different one. Is made up, one box made up of numbers, another box made up of colors. Okay, we are choosing one card from each box. Okay, so again, use a possibility diagram, guys, just like the previous one, to help you visualize what are all the possible outcomes that we can get from these two boxes. Okay, thank you, Daki, for sharing the live. Really appreciate it. So I become your broski now, is it? I don't mind. You didn't do okay for N levels to get into PFP. You did well. Congratulations, Ikan Bilis. Yeah. So in PFP, you're going to learn all the Sec 5 topics, right? That your friends are learning in secondary school. Yeah. So this is a good opportunity for you to pick up. So you can just follow us, our live on every Monday, 7:45 to 8:45. That will be when we actually go through all the O-level topics. Okay, 19 quick seconds to go, guys. 17 and counting. Okay, the correct answer is 1 out of 6, and 4 of you got this right. Okay, let's see how this is done. Okay, now, so if you were to draw the possibility diagram, right? Okay, because for the first box you get numbers 1, 2, 3, whereas for the second box you get colors. Okay, red, green, blue, and yellow. Now for this one here, how I presented my elements in the table was that I actually used like a coordinate system. So if I get 1 from my first box and red from my second box, I will actually write it as 1R. If I get 2 from my first box and blue from my second box, I write it as 2B. It's up to you lah, how you want to write it. You want to spell out the full words, go ahead, but this is how I did it. Okay, now, so based on what the question is asking for, they want you to find the probability that the cards drawn are a green card, must be green, and it must also be an odd number. So we're looking at these two favorable events there, or rather these two favorable outcomes. Okay, 1G and 3G. Alright, so 2 out of a total of 12 possible outcomes there. So that's why answer is 1 over 6. Okay? Can? So one thing good about the possibility diagram, right, is that it will show you all the possible outcomes that you can get from the two boxes. Okay? Now, but is there a limitation to the possibility diagram? Have you thought about it? What happens if I were to add in a third box? Is it possible to still show your answers through a possibility diagram? Okay, definitely cannot, right? Because unless you go 3-dimensional, okay, you're looking at a 3-dimensional box. Yeah, so that's the limitation to a possibility diagram. It's only useful if you are looking at a 2-dimensional problem whereby you just have like 2 picks or taking things from 2 boxes. But the moment you have a third box, that's where a possibility diagram might not be very useful anymore. Okay? Okay, moving on to the next question, question 9. Okay, now we're moving on to a tree diagram. Okay, so I hope you guys still remember your tree diagram. Okay, can you guys read the question carefully? Okay, now bear in mind that the competition ends whenever there's a team that already win 2 games. So if there's a team that already win 2 games, there's no need for a third game. Alright, so bear this in mind. Alright, so if you already play twice and you have, let's say, Bravo winning in the 2 games, then there won't be a need for a third game. The game would stop on the second round. Okay, so think about it, draw your diagram very carefully, because yeah, for the the moment you have two games won, then that's where the game will stop. Okay. Still got some more time. I gave quite a number of quite a lot of time for this one. Hi Faye. Hi guys, those of you who just joined us, you can still join in the game. The game pin is 6963856. Those of you, we still have another 4 more questions after this. Alright, so there are still 4 more questions after this. Okay, you can give it a try. The 4 questions are, just to warn you, it's going to be quite challenging. Okay, the last 4 questions are quite challenging as compared to the earlier ones. Okay, so it's a build-up of the difficulty from the first few questions all the way until the last question. Okay, the last question is super simple lah. Okay, it's slightly different from what you normally have. Okay, but you know the other questions from 10 to 12, they are a little bit more challenging as to what we've seen before. Hi Mao. Hello, those of you who just joined us. Okay, I'm Coach Hakim from MasterMaths, and we are actually having a free revision on probability. Okay, so this is meant for the O-level students. If you're Sec 4 or Sec 5 students, do join us. Okay, we still have about 4 more questions right after this. Okay, the game pin is 6963856. Alright, yeah. Okay, yeah, so that's the answer, 175 over 256. Only one of you got this right. Okay, this is something that you, oh, okay, an expert unicorn got it right. That must be the person. Okay, well, congrats to you who got it right. Okay, let me explain to you how this is done, guys. Okay, so this is how the diagram will actually, the tree diagram will actually look like. Okay, now, so you play the first game, right? There's a path whereby B wins. So if you observe the first part, right, this part here, this is the first game. Okay, so it's either B wins or D wins. Okay, either Bravo wins or Delta wins. Probability of Bravo winning is 5 over 8, right? This means that the probability of Delta winning is 3 over 8. They must always add up to one whole. Okay, the branches, the sum of the branches coming from one point must always add up to one whole. Okay. Now then for the next game, okay, so let's look at the one at the top. We branch out again, B and D. Alright? And then for the D also, we branch out B and D. Now, however, I didn't branch out further from B. Notice the first B at the top. Okay, can you guys look at the first B there? I didn't branch out. Okay, can you all tell me why? Why is it that there was no branching out from the first B at the top? Okay, can you guys type up in the chat? Why? Why is it? Why is the B just stop? Why does it stop there? Why didn't I continue? Because the game will stop once you have win 2 matches, right? So the fact that Bravo has already won the first round and the second round, it stops there. Okay, you don't have to play a third game because confirm already, okay, that Bravo will win. Okay, now whereas if you look at the second one, okay, the BD, we will after B wins the first game and D wins the second game, it's still open. Anyone can still win after that, which is why they played the third game. All right, and that's why for B and for the second one and the third one we branch out, but for the first and the fourth we don't. Okay, because for the first one, Bravo already wins. For the fourth one, Delta already wins. Okay. Now, and once you've drawn your tree diagram, right, to calculate the probability that Team Bravo wins the competition, we are looking at the one that I highlighted in pink. So the ones that you see highlighted in pink, right, guys, are the ones that we want. In other words, for Bravo to win, it must either have 2 wins, okay, which is Bravo wins first one, Bravo wins second one. Or another possibility is Bravo win first one, Delta wins second, but Bravo wins a third time in the third round. So that's 2 possibilities. So it's 5 over 8 times 5 over 8. That's the probability of, okay, maybe let me just go back to that question. Yeah. Okay, so let me explain to you through this, guys. I think this is better. This is where Bravo wins the first game and Bravo wins the second game. This is where Bravo wins the first game, Delta wins the second game, and Bravo wins the third game. Okay, and finally the last one, okay, this is where Delta wins the first game, but Bravo wins the second and the third game. So in these three cases, right, Bravo actually wins the game because Bravo wins 2 games out of 3. Okay, so we add up these 3 cases, this one or this one or this one, and that's how we get this. Okay, so just remember that when you have this case or this case or this case, all translates to a plus. Okay, whereas if you're looking at this part here, it's going to be a times because we're looking at Bravo winning the first game and Bravo winning the second game. Okay, I hope you guys understand from that explanation there. Okay, so let's go back to our game. Okay, any questions that you like to ask? Okay, if not, let's look at the next one, guys. Okay, question 10. Okay, this is where it gets slightly challenging. Okay, another tree diagram question. Okay, now take note, guys, that for this question here, we are looking at people, okay, students who are actually tangible things, right, living things, right? So we're tangible things. So the moment you choose a student, whenever a student is selected, what's going to happen is that in the second round, when you want to choose again, the numbers change. All right, so bear this in mind. Okay, in other words, this is like this is a no replacement problem. Hi Harith. Hi Kushairi. Okay, so be very careful here. Bear in mind that whenever you have selected a student from the first pick, okay, in the second pick, the numbers will change. Okay, yeah. Right, we have another 56 more seconds. Okay, suddenly the chat group became very quiet. What happened to you guys? Are you all like trying your best, keep cramping your minds to answer the questions? Hi Sira, how are you? Gila, what happened? Why are you panicking? Okay, 12 more seconds to go, guys. If you haven't typed out your answer, this is a good time to do so now. Oh, okay. Alright. Okay, let's take a look at the answer first. Yeah, good. There's 5 of you got this right. Well done, well done. Okay, let's take a look at this one. Let's take a look at how this is done. Okay, top 3 didn't change, only the 4th and the 5th changed. Okay, that's nice. Alright, so Expert Unicorn is taking the lead by quite a bit. This is question number 10, right? We still have 3 more questions. Okay, the question 11 and 12, right, guys, will be double points. Okay, so if you still do well in questions 11 and 10, you can still change the leaderboard. Okay, so the next 2 can actually cause a lot of changes in the leaderboard, despite seeing like a a big difference in terms of points. Okay, so keep trying, guys, because the next two questions are double points. Okay, but before that, let's take a look at how we do question 10. Now, this is a no replacement problem. In fact, sorry guys, in fact, when it comes to questions, probability questions, right, if they don't say anything, then what we do is we are going to assume that there's no replacement. So that's the default. Okay, you always assume that there is no replacement unless the question says otherwise. Okay, so this is a no replacement problem. Okay, which is why, right, okay, when you choose when you choose it the first round, okay, maybe again I go back to my notes. Yeah, okay, so this is where we actually do the first pick. Okay, in the first pick, there's a probability of getting for the probability of getting a male student, right? It's 7/15. Probability of getting a female student will be 8/15. Now, what happens in the second pick is this. Okay, now because of the fact that here you are choosing a male, right? So what happens is that the probability of getting another male will now differ. It won't be 7/15 anymore, because after choosing one male, that male student is going to leave the class, right? Your teacher's left with the remaining students. So there are 6 males remaining, and the denominator also changes. Now you have, instead of having 15 students, because that one student was already selected, you have 14 students left. The number of females didn't change, was still 8, because here we are choosing a male. The denominator, however, changes because like the total number change. Okay, just a quick check. You must see that these add up to 1. These add up to 1. So if they add up to 1 means, yeah, you have a chance that it's correct. Okay. Now, whereas if I were to go through this route, okay, notice that now in the second choice, in the first pick, I'm choosing a female here. So the number of females here will get reduced by 1. So notice from 8 becomes 7. The total will also be affected. From 15 becomes 14. Alright, the number of males didn't get affected is still 7, because this is the case whereby you are choosing one female in the first pick, and then and the denominator, however, still becomes 14 because you got one student less. Okay, yeah. So, and the favorable one, because the questions here says that you want to find the probability that one student selected is a male and another is a female, right? Okay, you got these two possibilities. One is male first, followed by female, and another one is female first, followed by male. These are two cases that you got to consider, guys. Okay, so in probability, there's a difference, male first and female second versus female first and male second. So you got to differentiate between the two. They are two different outcomes. Okay, so this is male and female. Okay, whereas this is female and male. And that's how we arrive to the answer of 8/15. You guys okay? Alright, so that's how we do question 10. Okay, guys, so get ready, guys, for the next one. Okay, because question 11 and question 12, they are both double points and they can affect the leaderboard. Okay, so even though it seems like the first one is quite far from the rest, right? But I think with the double points, things can change. Alright, so are you guys ready for question 11 and 12? Okay, let's look at 11 first. Aiden, why you left? Okay, now question 11, we have 10 red marbles, 3 blue marbles, and 2 white marbles. Ethan picked 2 marbles at random. Okay, what's the probability that he picked not 1 marble but at least 1 white marble? Oh, you went to have your dinner. That's nice. Okay, the keyword here is at least 1 white marble. Okay, so this question here, there's double points, so you might want to answer this very carefully and also quite quickly if you want to change the leaderboard. Hi, those of you who just joined us, I'm Coach Hakim from MasterMaths. We're actually doing a live stream on probability, so it's a free revision for our viewers. The topic for today will be on probability, and it's meant for the O-level students. What do you have for dinner, Aiden? I haven't had mine. Okay, we still have another 2 more questions after this. So those of you who wants to join us during for the game, right? You can do so. Yeah, just key in the game pin 6963856. All right, 6963856. Okay. Hi, those of you who just arrived. Not yet, Dila, because just now I just had a class. Wow, Wingstop for dinner. I'm so jealous. Yeah, so I'm having dinner right after this. Don't worry. I got a lot of reserves anyway. See all this? Yeah. Actually, I quite like it, Wingstop. However, the price is painful. Hi, those of you who just joined us, I'm Coach Hakim from MasterMaths. We're doing a probability today. Okay, be careful with the word at least, guys. At least 1 white marble means you must have a minimum of 1 white marble. Okay, so it's not find the probability of getting 1 white marble, but rather finding the probability of picking at least 1 white marble. Okay, it makes a big difference. Day and night difference. Okay, so 9/35. Wow, we got 5 students who got this correct. Let's see whether that changes anything. Okay, wow. Expert Unicorn still leading the way. But don't give up, guys. There's still one more double point question in question 12. Okay, good. Wow, lovely. Lemmer, I haven't seen you there. This you suddenly overtake after doing the double points. Okay, that's nice. Okay, let's take a look at how this is done, guys. Okay, now here are the possibilities. When you want at least 1 white marble, right? Okay, there are several cases to consider here. Okay, you can either get both white, because remember we are doing 2 picks, right? So both can be white, or you can have 1 white, or the third case is where you have no white at all. Now, because the question wants you to find at least 1 white, right? Means you are looking at the first 2 cases. You want both to be white, or you want one of them to be white. The only case you don't want, right, is the case where you don't have any white at all. So the third case is the one that you want to ignore. Okay, so instead of finding the first 2 cases, which involves multiple cases, right? Because if you guys also have to consider when they say 1 white, it means that you can have first 1 white, second one not white. Or there's also another case whereby the first one is not white, but the second one is white. Okay, so there will be like 3 cases to consider in total. White, 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 not white, and not white, white. So very troublesome if I were to do this. Okay, I mean, you can do it, no problem, but it's going to take you a longer time. I'm going to actually do a shortcut, and this is something that you guys can actually use. You can use the complementary approach, because when you want to pick at least 1 white marble, right? The case that you don't want is the case whereby you have no white marbles. So I will use the complementary approach here, guys. It's a shortcut. It makes things a lot easier, and you're able to solve this question way faster than your friends who go and use the conventional approach. Okay, so I'll take 1 minus the probability of no white marbles, because this is the case that you don't want. This is the only case that you don't want. So no white marbles means, okay, then let me explain to you how I got my 13/15. Now 13/15 is the probability of not getting a white marble, because if you look at this question here, actually it doesn't matter whether it's red or blue. What matters is whether it's white or not white. So I kind of like recategorize them. Okay, I change it to like 2 white and 13 non-white. Okay, so which is why I have 13/15 here for the first non-white marble. For the second non-white marble, right, because this is a no replacement problem, the number of white marbles is going to be reduced by 1, because you already took out 1. Okay, 1 white marble has already been taken out from the back. Now you have 1 white marble less. And the total also changes. Instead of 15 marbles, now we have 14 marbles, 1 marble less. Okay, and that's how we get 9/35. Okay? Okay, I hope you guys can understand my explanation. Of course, you can actually use the longer approach to find the case whereby you have white, white, non-whites, and non-white, whites. But like I said, it's a lot of a hassle. This is the shortcut. This is the faster approach that I would use. Okay? Okay, let's take a look at the second last question, question 12. Okay, this is also a double point question. So this is a chance for you all to still catch up. Okay, or yeah, let's see whether it's still possible. Okay, question 12 for you guys. Okay, so you have 9 mangoes, 5 red apples, and 5 green pears. 2 fruits are taken from the basket. Okay, without replacement, and you're asked to find the probability that both fruits are of the same color. So in this game, right, in this question rather, we're not interested in the type of fruits. We're interested in the color of the fruit. I don't think the person will leave Kahoot. Not at the expense of the $10 voucher from Popular. Hi, Rina. Hi, Nina. Are you the lemon, Eden? Is that why you rooting for that person? You rooting for yourself? You like the underdog story, is it? Whereby someone makes a comeback from nowhere. We've got 3 answers so far. The rest of you, they still have another 80 seconds. Okay, now bear in mind that in this question here, the kind of fruit doesn't matter. What matters is the color of the fruit. Okay. Hi, those of you who just joined us, I'm Coach Hakim from MasterMaths, and today we are actually doing a free live stream on probability. It's meant for O-level students today. If you have any, we are into our second last question. All right, there will be one more after this. There'll be one more question right after this. And that will be the last one for today. All right, so this will be the last double point question. After this will be single points. Hi, those of you who just arrived, I'm Coach Hakim from MasterMaths, and we're doing a revision on probability today. We're actually into the second last question for today. We still have one more question to go. No worries, Orion. Okay, 6 seconds left, guys. Those of you who haven't keyed your answers, now is a good time to key in. 2, 1, and 0. Let's see how many got it right. Only 2 students. Okay, let's take a look at this one here. Okay, now this is actually quite a challenging question. Oh, I think Expert Unicorn got it right, and Lovely Lemmer. Wow, very close. I'm not sure. Maybe who's Lovely Lemmer? Maybe you wanna declare. Probably you join us a bit later, is it? Okay, guys. Now, as I was saying just now, for this particular question, the type of fruit doesn't matter. What matters is the color. So I'm going to recategorize it based on its color. So this is something that you can choose to do to make things simpler. Because it's no point looking at whether it's mango or apples or pears when our focus is on the color. Alright, so a smart way to do this would actually be to recategorize the question, or rather to recategorize the fruits into colors instead. So since there are 2 kinds of colors, we're looking at green or red. There are 17 green fruits and 5 red fruits. Okay, and to find fruits of the same color, there are 2 favorable cases, right? You can either be green or red. So green and green, because green and green means you're taking the property of green and you multiply it with another green. The property of red, and red means you're taking the property of one red and you're multiplying by the property of getting a second red. Okay, which is how we arrive to the 17 over 22. And then, 17 over 22 is the property of getting the first green fruit. 16 over 21 is the property of getting the second green fruit, because it's a no replacement problem. When one green fruit has been taken away, the number of green fruits becomes lesser, which affects the numerator, whereas for the denominator also changes because the number of fruits now reduces by 1. Okay, now the same explanation can be goes for the red one as well. 5 over 22 is the first red fruit. The second red fruit will also get affected. Alright, so number of red fruits becomes lesser, total number also becomes lesser. That's how we arrive to 146 over 231. Okay, so recategorizing is a technique that you guys can also use, especially when they are talking about, when they actually give you earlier descriptions that are not so necessary. You can categorize them into categories that now matter for this particular question. Since they're talking about color, we categorize them according to their color. Okay. One last question, guys. Okay, this one is very simple. I think you guys are able to do this. Okay, any questions that you want to ask about 12 before we move on to the last question? Okay, the last one is a motivational question. Let's take a look at question 13. Okay, you only have what's the probability of scoring at least 1 mark for a question that you did not attempt at all? Okay, 30 questions for this one, guys. Okay, I think quite easy, right, this one? Okay, you never attempt the question. What's the probability of getting at least 1 mark? Okay, good. Answer is 0. Well done. Alright, so I think this one is quite straightforward. Okay, if you don't attempt the question at all, right? Okay, it's just impossible. Okay, so if the idea that I want to actually bring across from this to this by giving this question is that I want you guys to always have this mentality, right? Especially at Sec 4, you guys are sitting for your major exams. Try your best to do all the questions there. Okay, attempt all the questions and just don't give up on a particular question. Okay, now, especially for those longer questions, those kind of paper 2 questions whereby there's multiple parts A, part B, part C, or part 1, part 2, part 3. Now, those are questions whereby sometimes, for those questions they tell you in part A, show something, and the answer is given. So if let's say you still cannot do that part A, alright, you can actually you can actually use the answer that was given in part A for part B and C. So always try to salvage as many marks as you can get for every question, because every mark matters. Alright, so give the question a try. You may not get, you may not get the full marks, okay, but at least try to get as many marks as you can. Alright, now this actually also goes to your, like the learning attitude and things like that lah. Alright, so don't give up. The moment you give up, right, then that's it. You already declare defeat for yourself. Alright, so keep on going, keep on trying. Okay, so yeah, hopefully, yeah. And so just want to share with you guys that we do have a free trial program. Okay, I'm not so sure why they split up the word trial. Okay, so you can actually feel free, if you're not a MasterMaths student yet, you are free to join us for a free trial, no obligations. You can just come to our lessons and then sit through our lessons for 1.5 hours and then see whether you like it or not, and then decide afterwards whether you want to join us in our tuition program or not. Yeah. So there's no obligations. If you would like to join us for a free trial, okay, you can actually scan that QR code over there, okay, or you can also go to our website, okay, mastermaths.com.sg. Okay, can? Alright, now to the very thing you guys are waiting for, this part here. Alright, the podium. Let's see who's number 3. Oh, lovely Lemmer. Okay, Aiden, this is your number 1 fan for Lemmer, right? Wow, 10,298. Let's see. Expert Unicorn. Well done. Wow. Okay. Expert Unicorn, can you take a screenshot? Okay, I'll give you can you take a screenshot of this podium standing Expert Unicorn? Okay, Okay, if you are here, you can type in the chat. I want you to actually take a photo, screenshot of this podium standing, and then I'm going to, you take ready the podium. Oh, Shen, well done. Congrats to you. Okay, Shen, have you taken a screenshot of this? Oh, no, you are Inspired Unicorn. Okay, so for the winner, right, have you taken your screenshot of the podium? Okay, because once you have done that, right, I need you to scan another QR code. Okay, hold on, let me find that QR code first. Okay, can you scan the QR code here, or you can go to the tiny URL there to actually update us on your details. Okay, because we are going to post you the $10 voucher right to your address. Okay, so this is where you actually give us the details of your address, your name and your address, so that we can actually send out the voucher to you. Okay, can. Sorry, Sharon, it's we're only giving out to the first prize. Yeah, no worries, no worries. Yeah, either next week you try to have dinner before class. Then after that you can actually secure the voucher, hopefully. Okay, so congratulations to our winner, all right, who gets this $10 voucher. Please take a who's the winner? Quite shy at this person. He's not saying, he's not chatting. Yeah, we're wondering who's the winner. Okay, I hope everyone else, okay, I hope the rest of you actually learn a little bit about your probability. Okay, I think this is a good opportunity to actually recap on your probability. Probability is actually, in O-level exams, based on what I've seen, sometimes it can come out as a question on its own. Sometimes it can come out as a question that is tagged along with statistics. Okay, some of you might not have gone through statistics yet, but I've seen before whereby, I think it's quite popular. It's quite easy to see questions whereby they actually integrate statistics together with probability. All right, so it's not really a very big topic, but I think it's a topic that's quite easy to score. All right, so do spend time, especially you need to know when to add probabilities, when to multiply probabilities, and I think I shared with you some tricks, right? Like when to use the complementary approach to make your working a little bit shorter. All right, so I hope that you guys have enjoyed the session and have benefited from the session. Okay, and yeah, next week we will be doing another O-level topic at 7:45. So stay, I'm looking forward to see all of you next week as well. And yeah, we'll be starting at 7:45. In terms of the topic, we haven't discussed yet, but we'll let you know on the day itself. Okay? Alright, so have a good day, guys. Have a good rest. I'll see you guys next week. Alright? Bye-bye. Oh, Aiden wants to have a talking session. What do you want to ask, Aiden? Hey, bye, Sharon. Second place is still good. Alright, next week we're going to try again. Which school are you from, Sharon, by the way? Aiden, which school are you from? Oh, it's plus and it's times. Yes, correct. Ah, Manjusri. Okay. Are you a MasterMaths student? Oh, Aiden is from North Vista. That's nice. Okay, if there are no questions, then I'll see you next week, guys. Alright, looking forward to see you guys again. Sharon and Aiden. Alright, same time, 7:45, alright? Alright, take care, guys. Bye. Good night.